Welcome to another tutorial video from Cert Maths. Make sure and subscribe for more. In this video we're looking at algebraic identities. Algebraic identities are basically when the left-hand side of an equation equals the right-hand side of an equation. And they'll be asking us to find what are known as unknown coefficients. The coefficient is basically that number that's in front of the x. So they're basically getting us to find the value maybe of a or b, the numbers that are in front of the x's. Now in this video we're looking at maybe 4 or 5 different examples, starting with a few easy ones in example 1 and 2, and then when we get down to example 4 and 5, a little bit trickier, and I've taken those from your text and test book. It's the Leaving Cert Maths book, which also includes partial fractions, our last example here in the video. So let's start with example 1 and 2, which are a little bit easier, but that they'll introduce us to algebraic identities. So we're used to looking at questions like this, that they ask you to solve for x squared equals 9, so you're using your square root. This question wants the values of x, so just remember when you're solving this identity that x is going to equal the square root of 9, and the square root of 9 is giving you a positive 3, but it can also give you negative 3, because remember that I can multiply 3 by 3 to get 9, or I can multiply negative 3 by negative 3 to give me positive 9. So when you work out a square root, you have your two values. So I'm going to say here that x is equal to plus or minus 3. So that's how we write our answer for the values of x. They can be plus 3 or negative 3. Coming over here to example 2, they want us to find the values of both a and b. So there are values here. So they're telling us that it's equal, bx squared plus ax is equal to x cubed or 3x cubed minus 2x. So again, you can see here that there's very little work to do. All you're doing basically is pairing up the coefficients of the x squared. So first of all, I'm going to look at my x squareds and I'm going to match them up. So I have bx squared, so the one on the left hand side of the equals, is equal to the x squared on the right hand side of the equals, which is 3x squared. And you can see straight off that b then must be 3. So I'm just going to say therefore, so my 3 little dots, b is equal to 3. And now I'm going to find the value of a, and a is the coefficient of just the x, the degree of 1. So I'm going to say my little work here, so I'm finding the coefficient of the x, which is going to be ax is equal to minus 2x. So just be careful with the signs in front of any values. And the coefficient of the x is a and negative 2. So therefore, a must equal to negative 2. So there are two basic examples of using algebraic identities. So you're trying to find those unknown coefficients, the value of the number or the letter in front of the x. So let's have a look at another example. So they're telling us that these are equal. Again, you have this equal sign, which is showing that 3x minus 2 times x plus 5 is equal to 3x squared plus px plus q. And they're trying to get us, which is important, all of the values for x. So they're telling us that their values exist for p and q. So first thing I would do is always ignore perhaps the right hand side of the equals, because it's complete for us. There's nothing I can do to this. It's already expanded. So what I'm going to do here is on the left hand side, I'm going to multiply out these brackets. So see my two brackets here? I'm going to multiply those out. So when I multiply out my brackets, I'm going first term by second bracket, which is my 3x times my second bracket, which is x plus 5. Then my second term, which is minus 2 times my second bracket. And that is all equal to 3x squared plus px plus q. And when I multiply in my bracket, I multiply the 3x by the x to get 3x squared. I multiply the 3x by the 5 and I get plus 15x. I multiply the negative 2 by the x and the negative 2 by the 5 to get minus 2x minus 10. And that is equal to 3x squared plus px plus q. On the left hand side, I can group the 2x, minus 2x and the plus 15 to get 3x squared plus 13x minus 10 is now equal to 3x squared plus px plus q. And I've gone as far as I can on the left-hand side. So now I'm basically just going to match up or pair up the degrees of 2, the degrees of 1, and then the constants. So my first one's my x squared, so let's pair them up. I have a 3x squared, which is coming from here, and that's equal to the 3x squared on the right. So that's fine. There's nothing I can do or need to do there. So there's very little to do. 3 is equal to 3, but I've just done it nonetheless. I'm now going to come over to my degree of 1, x to the power of 1, and I'm now matching up the plus 13x and the plus px. So I'm pairing up, as I said, the plus 13x and the plus px. So what does that give me? That's giving me 13x is equal to px. So that means I can divide both sides by x, or in other words, they can cancel out. So 13 is equal to p. And there's my value for p. And now I'm going to come to my constant, the number on its own, which is my q. So I'm just going to write constant here. A constant is a number that doesn't have an x. And I'm going to pair up the minus 10 with the q. So that's telling me that q is equal to minus 10, isn't it? So minus 10 is equal to positive q. So therefore minus 10 is equal to q. Or you can rearrange them. Q is equal to minus 10, whichever way you want to write it. So that's example 3, getting a little bit more in depth with our algebraic identities. Let's go down to another one. So it's example 4, and it's telling us that 2x squared plus 5x plus 6 is equal, again that equals is vital in these questions, p times x plus q all to be squared plus r. And they want us to find all of the values for p, q and r. So again, write it out, and we're going to put our equal sign between them. So 2x squared plus 5x plus 6 is equal to p times x plus q all to be squared plus r. Now you can see on the left hand side there's nothing to do. It's 2x squared plus 5x plus 6. I can't break that down any further, so I'm going to come to the right hand side of the equals. Now there's a little bit of work going on here, because you can see that I have to multiply it by a p, and I also have to square it. So you have to think of your rules of BIMDAS there. So BIMDAS, if you remember your BOMDAS, remember that you have to do brackets first, then indices, and indices relate to the powers. So you need to do the squared before you do the multiplying by p, because multiplying comes after the power. So what I would do in that example is I would bring in my own brackets here, and I'd put a square bracket or another curled bracket around the p plus q, or sorry, the x plus q all to be squared. So I'm going to do that section first of all, and then multiply my answer by the p. Okay, so bring in those extra set of brackets if needs be. So that's giving me 2x squared plus 5x plus 6 equals p times x plus q squared. X plus q squared basically means x plus q by x plus q. That's what a squared means. So it's x plus q times x plus q, and I close my square bracket, and don't forget I have to add on that or at the end. I'm now going to multiply out those square brackets, so that's giving me first term by second bracket, so x times x plus q, and plus q times my second bracket, which is x plus q. Close my square bracket, make sure that that is all being multiplied by p, and plus or at the end, and that is all equal to 2x squared plus 5x plus 6. I'm just going to continue my next step. Again, always show each step for an examiner in case you make a mistake. I'm multiplying in these brackets now, x by x and x by q and q by x and q by q. So that's my next step now. So x by x is giving me x squared. Q by x can be written as xq or qx, it's up to you. I'm just putting the x after it because we're trying to find all the values of x. And q by x then in my second bracket also gives me qx. And q by q is q squared. And don't forget, once again, to put your plus or at the end. So that's giving me 2x squared plus 5x plus 6 is equal to p times, and now I'm just going to group my qx plus my qx. So that's telling me that I have now got two qx's, so it's x squared, plus qx, as I said, is 2qx, plus my q squared, plus my r. Now I'm going to multiply by that factor of p. I'm now bringing in this p outside. So I'm now multiplying that in. So I'm multiplying it into each of the three terms in my square bracket. So it's p by x squared, which is giving me px squared. I'm then multiplying the p by the p multiplied by 2qx. Some tongue twisters going on here. So that's giving me plus 2pqx. Again, the order of the letters doesn't matter. And then my final step is my p multiplied by the q squared. So that's giving me plus pq squared. Don't forget, add in your plus or that's at the end. And that is all equal to 2x squared plus 5x plus 6. Okay, so a bit of work to get to that step. Next thing I'm going to do here is just rearrange that right-hand side, because if you look at the left-hand side, they've put it with the in order. The squared comes first, then the degree of 1, and then the constant. So I'm just going to make sure that everything is in order, and it is. It's px squared, then it's followed by the x. Now, this step can sometimes confuse people. It's written as plus pq squared. There's no x associated with that pq squared. So that pq squared is a constant. It's a number. So don't go rearranging it to bring it over here with the x squared, because it doesn't have an x. So now I'm going to solve for p, q, and r. So I'm now first of all going to look at my degrees of 2, my x squared. So I'm just going to scroll my screen down here a wee bit. So that's giving me with the 2x squared. X squared is equal to px squared. So we have x squared is equal to 2x squared is equal to px squared. And if we divide across by x squared, we get p is equal to 2. So that's our first value found. There's our p. Now we're going to come over to our degrees of 1, which is just x to the power of 1, or just our x, which is giving us 5x is equal to 2pq. Now we found the value for p, so we're going to sub that in. So I'm going to divide across by x first of all. So when I cancel my x's, I have 5 is equal to tpq. I'm going to sub in 2 for my p, so I'm drawing a bracket, q, and I'm going to sub in 2 because we found that in the first part. So that is giving me 5 is equal to 4q. And that means then that q is equal to 5 divided by 4, or 1.25. And now we're going to come over and we're going to find our constant. And that is giving us 6 is equal to pq squared plus r. So we're trying to find r in this case. So 6 is equal to p times q squared plus r. I'm going to substitute in my p, which is 2. And I'm going to substitute in my q, which is 5 over 4. And when I work that out, I get 6 is equal to 5 over 4, which is 25 over 16, which is 50 over 16 plus r. A little bit of algebra, add or subtract 50 over 16 from both sides, or move over to 50 over 16. So we get 6 minus 50 over 16 is equal to r. So r is equal to 23 over 8. So that's the value for my r. And there's our three values. We found our p, q, and r. So let's look at our partial fractions question. So with our partial fractions, you need to find your common denominator first of all. So over here to the right hand side, I've just put out some rules here that might help to guide you through how to do our partial fractions question. So I'll just leave that to the side there. So the first step is to get your common denominator. Now you'll notice on these that your common denominator will always be found on the left hand side. So you can see what your common denominator is. It's basically given for us. It's when you multiply the denominators, which is your x plus 1, which is this one here, multiplied by the x take 1, which is this one. So I'm basically multiplying the two denominators, and that's my common denominator. My next step then is to factor that into my fractions. So let the top lines of the fraction equal to each other once we sort out our common denominators. So I'm just going to write out my question here. So it's 1 over x plus 1, x take 1. And then it's equal to, and I'm now going to write out my two fractions again, but with my common denominators. So it's my x plus 1 times my x minus 1, x plus 1 times my x minus 1. So I'm bringing in my common denominator there. Now I already have the a on the top of my first fraction and the b as the numerator on my second fraction. And basically look what's happened here. On my first fraction, I've brought in the x minus 1 on the bottom. So if I bring in the x minus 1 on the bottom, I must multiply the top by x minus 1. And it's the same on the next fraction. I've brought in the x plus 1. So that means I need to bring in also an x plus 1 on the top. I need to balance out that fraction. Whatever I do to the bottom, I must do to the top. I'm now going to just multiply in my top line. So I'm going to multiply the a into my bracket and my b into my bracket. So that's giving me 1 over x plus 1 times x minus 1 is equal to a by x, which is ax, a by 1, which is minus 1a, and that is plus b times x and plus 1b, all over my common denominator. The next step now is when you add these two fractions together. So I'm basically just going to put them as one fraction. So it's ax minus 1a plus bx plus 1b all over my common denominator of x plus 1 times x minus 1. So I'm just adding the same fractions with the common denominator, because it's like this question. If I had 3 over 7 plus 2 over 7, I add the tops and I get 5 over 7. So that's all I'm doing there. I'm adding the fractions together. And that is equal to my left hand side, which is 1 over x minus 1, x plus 1. If you look up at my steps here, I'm going to say step 2, let the top lines of the fraction equal to each other. In other words, I'm crossing a line through the denominators because they are now equal to each other. X plus 1 times x minus 1 is equal to x plus 1, x minus 1. So I'm basically just cancelling out the denominators. I'm forgetting about it for how I'm going to solve my fractions. So therefore, 1 is equal to ax minus 1a plus bx plus 1b. I'm just going to rearrange it. So I'm going to put the x's first, followed by my constant. So that is 1 is equal to ax plus bx minus 1a plus 1b. And I'm now going to just factorize out this x. So 1 is equal to a plus b times x minus 1a plus 1b. So I've just factorized out that x. I'm now going to just bring it up here just to keep it all on the one page. So I have 1 is equal to a plus b times x minus 1b or 1a plus 1b. So just rewriting the left hand side, that's the same as me going, I'm bringing in the 0x. I don't have any x's on the left, but I'm bringing it in so I can match it up with the x's on the right. So it's 0x plus 1 is equal to a plus b times x minus 1a plus 1b. So see what I've done? I've just brought in that 0x because that means then I can match them up. So I'm looking at my x terms and then I'm looking at my constants. So if I look at my x's, I have 0x is equal to a plus b times x. If I divide across by that x or cancel them out, I get 0 is equal to a plus b. So that means, therefore, a is equal to minus b. I've just moved the plus b over to the left-hand side of the equals. Or I've subtracted b from both sides, basically. And then I come to my constants. I have 1 equals minus 1a plus 1b. And what I'm going to do now is I'm going to sub in minus b equals to a. So we know that from the first part. So I'm going to substitute that in. So it's 1 is equal to minus 1 times my a. And my a is basically minus b. So I'm subbing in that minus b from here. And minus 1 by minus b gives me a plus b plus 1b is equal to 1. So 2b is equal to 1 over 2. 2b is equal to 1, I should say. So that means that b is equal to a half when I divide across by 2. So therefore, since we found the value of b, so minus b is equal to a, so I'm going to substitute in my half for b, so minus a half is equal to a. And there are my two answers. I have b is equal to positive a half, and I have a equals to negative a half. And that's what they wanted us to do. They wanted to solve for the values of a and b. Thank you for watching another tutorial video from Cert Maths. Make sure and subscribe.